Hello and welcome to Architecting Software Quality live chat with Andre. Today, today is April 1st, and today is just a beautiful day to do one of the first lives we are going to do. Today, we are going to talk about unit testing, and my guest today is Bill Schiller. Bill Schiller is a software architect who is specializing in identifying and applying best practices in design and automating testing for embedded systems. So he's worked in software development for over 20 years on various products in both industrial and medical devices. In his current role, he is a lead software architect at Smith Medical. Bill's a really great guy. You'll meet him today, and he has a broad range of responsibilities across the software group, basically defining software architecture and supporting ongoing development for the company. What's interesting for me was he has deep experience with embedded systems and embedded Linux and specializing in practices such as test-driven development. His what I learned about him is his strengths and passions are around how can we reduce the overall cost of ownership of software testing and software development by applying practices such as automating builds and automating software quality checking. So with that, without further ado, I am going to introduce Bill into the studio here. Hi, Bill.
Hello. Thanks for having me. I'm honored to be part of your some of your early talks here. I listened to your other one; it was really good. So
All right.
hopefully we can do a good job.
Thank you for the kind words. So today is April 1st, and it's not an April Fool joke, our broadcast today. And we are going on this sunny day. We have a very cool, very crispy and sunny day here in Minneapolis. But then we are going to talk about something very, very painful. We're going to talk about unit testing, right? So that's a subject that developers love and hate, and it's very kind of dividing the industry in many aspects. And one of the first questions for you, Bill, is so people talk about unit testing, and the second they start talking about the unit testing, there's a question of the definition of a unit comes up. What is the unit?
Hmm.
And that leads us to the discussion of integration level testing. And people want to jump from unit testing directly into integration level testing and without even kind of seeing the value of or difference between the both things. So, from
Hmm.
your perspective, Bill, what's your take on this topic, integration testing versus unit testing?
All right. Well, I would say, I mean, that's one of the key parts of all the testing, especially at the developer level, to think about. Oftentimes, developers, especially in the embedded space, when they think of unit testing, they're really thinking of something more like an integration test. I think of unit tests down either to the functional level or to a class level if you're doing C++ or a module level if you're doing C. And a lot of times, developers are used to working more at where they have a small part of their application compiled and they're using the command line interface and they're running tests at that level, which is a really great high value test. Probably the big challenge there though is that what happens is the integration tests grow and grow and they don't really what's the right way of saying it, they'll find problems but they won't tell you where the problem is. You'll have this large test that fails and you're like, oh
Mhm.
no, and all the developers kind of look in horror and go, how are we going to go fix this? And I have an old colleague that was a sharp guy and had a passion for unit testing too, and he once said that the integration test tells you that your subsystem is working, where the unit test will tell you where it's failing. And we found this and proved this out where we built up a layers of unit tests and integration tests, and when the integration test would fail, um, either a unit test would fail or we would build up and have a unit test that would help us show where it was failing. So I think that's a big key. It's dividing components down to smaller levels so that you can really have confidence at the smallest level, the smallest unit, that it's actually working as you're expecting.
Mhm.
And that's kind of one of the big differentiations. But Yeah, I think what you end up finding too, and it seems just from my experience that the deeper you go into smaller embedded systems, it's more common to see integration tests. People think of this lower level testing as integration. That's a fine area to
Right.
try to pick apart.
Mhm. Yeah. So what I've seen in kind of my experience with this area is integration tests potentially finds different level of defects, different
Hmm.
type of a defect. Maybe it's a synchronization defect. Maybe it's some sort of a already a requirement missing or requirement is incorrectly created. But then unit testing are finding more of a structural defects.
Hmm.
And what's interesting to me is that I noticed that when people, I don't know if you notice the same thing, when people start creating unit tests for the code that they've written, they
Hmm.
realize that the code itself could be improved, the interfaces could be cleaned up, and then the handling of the external stimuli into that unit could be done a lot more robust in a robust way. Are
Yep.
you seeing something similar in your observations?
Absolutely. I would say, I mean, I've been doing unit testing, for over 15 years now, and what happens is, and you see this with younger developers and senior developers that are learning it. I'm in my role, I do quite a bit of mentoring and training of people at multiple levels, and what happens is the object-oriented programming, the styles and the approaches that you would do. A lot of it, I would say, in my own experience, that I actually really learned programming when I was doing unit testing. Like, how do you really design to an interface? How do you use dependency injection? That's like one of the foundational things for unit testing is to especially in the object-oriented world. It becomes less common as you move down into lower level C programming. But if you're looking across the industry and you're looking at people that do unit testing, dependency injection is kind of like a key phrase where they say, how do you inject a dependency into this class that I want to test? So that you can really test the class's logic by itself without having it rely on multiple things. Kind of one of the common, even the one of the most common ones is even something that relies heavily on time. You'll see like a different algorithm that relies on, let's say you have a control algorithm and you want to really just test the algorithmic logic through it. Well, if you want that algorithm to run at 10 milliseconds or 50 milliseconds or whatever it is, it can be very fragile to unit test it. And you can't really test, well, what happens if we miss a cycle? What happens if we go 100 milliseconds? What happens if we go 10 milliseconds twice really tight back to back? And that's where dependency injection comes in. And so just layering and just adjusting your code a little bit so that your algorithm takes the time instead of interrogates the time internally. And that
Mhm.
so basically you're exposing the dependency in this algorithm that it requires. It's expecting the time. And now
Mhm.
you can say, well, here you've executed with a 5 millisecond offset. Now here you've executed with a 100 millisecond offset. And you can test how your algorithm behaves in that way in a very tightly coupled way. Or if you try to unit test it and you're actually using the system time, it'd be virtually impossible to really kind of dither back and forth on those edge cases. And to me, that's part of how you end up doing design changes. It's really around how do you push the dependencies into your code and how do you make it
Mhm.
obvious that those are the dependencies.
Right, right. And one of the interesting things that come out of the even creating unit tests is developers potentially realize how painful it is to test your code
Hmm.
if you have a particular architecture. So the architectural patterns to structure the code in a more testable way are
Hmm.
becoming more prevalent if your organizational culture encourages people to spend time to properly unit test the code.
Yeah. Yeah, I would say what you're kind of touching on there is is there's a lot of interesting points around that, because what ends up happening, that was one of the in my current role, that was you talked about the organizational
Hmm.
change, and people often think, you're an architect, you put your hat on and you think about how you're going to do these different things, and you kind of sit in your back room and you send out emails and update UML and tell people how to do it, right? uh, but the reality is, a lot of my time, especially early on, is spent with managers, saying, these are the kind of things that I'm expecting people to do. And these are the kind of patterns I'm expecting them to follow. Developers, if developers have some involvement in writing the unit tests, their code becomes more testable. But it also becomes, all sorts of metrics come out of that too, right? You start looking down at your code and you're like, the complexity starts to go down, because you don't want to you don't want to test this highly complex multi conditional function. You want to test something that's simpler. I mean, there's other ways to get people to reduce their CCM in their code, of course, but um, I mean, as a software engineer, you have to kind of embrace your trade and say, what is the value here in me kind of really learning how to build something that's easily testable, simple, modular. I mean, this is kind of ultimately the goal of almost all program development, is to try to get to that
Hmm.
development environment where you really have a nice, clean design, and testability comes out of that. It goes, they're complementary disciplines, is what I guess I would say. If you're
Got it.
writing testable code, you're writing well-designed code.
You're absolutely right. Yes, it just comes hand in hand with
Yeah.
if you architected your code well, it's testable, and if it's not architected well and there's no culture of taking the time to architect it well, it's not going to be testable. Hence, you will pay the price in the back end, I guess.
Exactly.
Part of your job, I understand, it's articulating that to the management. If you like, let's just take a left turn here. If
Hmm.
you were to give one advice to other architects in the same position, what would it be? What would that be? One tidbit of your knowledge, your background, and if some other architect similar to you but in a different organization is listening to this or watching us live here, what would just one thing that you would tell that person to do? Hey, don't do this or don't do that. What would it be, if anything?
You mean from just a general architecture, or is it more kind of related to testing, or?
No, just a general advice. You want, let's say, you want organization to change towards transitioning towards more building more testable units, having a culture of producing better software
Uh-huh.
by doing maybe test-driven design, or have some have some time spent on architecting the components better. And then
Hmm.
there's a push from management. It's like, no, 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 we don't want to do it, right?
Hmm.
We're busy doing other things,
Yeah.
which is very common situation. And
Yeah.
you're trying to steer the ship,
Yeah.
and from one captain of a ship to another, what would you tell that other architect?
Yeah, it's a good question. I think probably, maybe I'll speak to people who are maybe new or wanting to be in that architect role. There's a lot of I think there's this notion of everybody likes the kind of big picture. I find developers love, you got into software development because you love creating something and watching things actually interact and work and run in an automatic way. There's something about all of us that's why we do this, right? And being an architect is like a natural next level beyond that. It's where you're still in there and thinking about things at a higher level. And I think the different people I've worked with over the years that have been good at moving up, um, really are communication. Communication has to be a big part of your toolbox. You have to be. You're going to get resistance from management. You're going to have to justify why you want to do these different things, why you want to spend the company's money for good reason, right? So you have to be good at really come up with some basic kind of ways that kind of find your voice of like, this is how I justify doing these types of things, whether it's a purchase of something or technology. How do you present it? How do you show it to people and expect that you're going to have to really have some of the soft skills, that you're going to have to be an evangelist, moving up and showing people the justification. Think about how it comes out in the dollars. There's more and more awareness in the industry over really the cost of ownership. I think unit testing and the most compelling argument for that has been, in my mind, talking to people and saying, here's the it's kind of how do we get out of the whack-a-mole problem? How do we get out of the problem of we fix
Mhm.
a bug and another bug pops up? And to me,
Mhm.
that tells me that you don't have
Mhm.
enough unit testing when you have that
Yeah.
problem. So you kind of get to do that. But I guess maybe kind of close off the thought that you had, or the question you have is, I would say, just be prepared that you're going to get challenged both ways. You're going to get challenged from the top down. You're going to get challenged from the team, because you're going to have, hopefully you have good, solid technical people that you're leading, right? And they're going to come
Mhm.
back to you and they're going to disagree with you. So be open to listening, but also appreciate that your job is to be an evangelist and a leader too. And you kind of have to lead in a soft way. You're not necessarily having people report to you, so you
Mhm.
have to really persuade people and kind of win their minds over.
Okay, yeah. In that journey of persuading people, let's talk about processes and metrics and tools that you're kind of want to enforce across the organization, or you
Mm-hmm.
want people to adopt and embrace
Mm-hmm.
across, let's say, teams.
Yeah.
How important it is, in your opinion, for the organization to have a uniform, agreed upon set of common tools and practices
Mm.
that will be kind of acknowledged and implemented in the correct way. How important that is for you, for the organization.
Um, I would say it's a to me that's a real foundational thing. It's it's um, it's no different than in many ways it's no different than a coding standard, right? I don't like to look at code and be able to tell that Andre wrote it, and I don't like to look at the next module and tell that Bill wrote it. I want to look at the code and say, this is project A's code, and it followed this coding standard. I look at each file, everything looks about the same. And in the same light, I've been in organizations where there wasn't any rigor around unit testing and frameworks, and you can maybe not know the person, but you can tell the year by the unit test. It's like, oh, those are the tests they were running 3 years ago. Those are the tests they brought in when they integrated this part of the project in. So the reason it matters, besides from just like the visual, like processing, is that you can't underestimate how much. Um, well, what's the right way of saying it? There's a psychology basis to it. You can handle like three things at a time, right? You maybe five for really smart folks. I'm three on a good day. So the more variables there are, the less your mind can focus on the one piece. That's why we do
Mhm.
object-oriented programming. That's why we follow standards, because the more you can look at a unit test and you can go right into it, and it's commonly formatted. The outputs are commonly reported. Um, you integrate it the same way in your tool chain. The more you can just sit down and look at the logic of the unit test and say, is this unit test correct? And that's where you want everybody to be. You want people to not be burdened with the thinking about
Mhm.
how to really create it and really focusing on how do I want to test this code. So I
Mhm.
think it's really a foundational thing. and
Right.
and it's not so important that you get the right one. It's important you get the right one for the team.
Mhm.
You'll be in some places where you have well, obviously technology matters hugely, right? So then,
Mhm.
but even in embedded environment, you'll have teams that have great variability. So different tools might be more appropriate for one group and might
Mhm.
not fit the next group at all.
Yep.
So
Yep. It's totally. So, for example, from my vantage point, I'm seeing that some of the tools are very graphical oriented. It's about clicking, it's about dragging and dropping, it's
Mm-hmm.
about like filling up the boxes with
Mm-hmm.
some data, right?
Mm-hmm.
And so that's one. And some people are very, very versed in the GUI like minded set,
Yeah.
right? And there is another school of thoughts, but which is right now it's getting a lot of traction there, especially in embedded space with prevalence of embedded Linux and kind of command line programming. So people
Mm-hmm.
want to just run things from a command line. They want to open VI. God knows why, but they want to open VI,
Mm-hmm.
gedit, and just kind of edit things from command line. Maybe it's just because people are dealing with remote servers more and
Mm-hmm.
more, and then having the distributed programming forces you to be more command line friendly. I don't know,
Mm-hmm.
maybe it's the new CI/CD DevOps revolution
Yep.
where everything has to be structured as code, right? But I'm seeing that kind of a it's kind of oil and water.
Yeah.
Some people are more
Yep.
gravitating towards, right? Yeah.
Absolutely. Yeah, and I'm not. I think that kind of fits in with the team,
Hmm.
right? You got to like
Yeah.
look at your group and see how you're going to tailor it to the team for
Hmm.
sure.
Exactly. So, in the closing topic, I want to briefly talk about on target unit testing versus
Mm-hmm.
not on target, right? Versus we call
Mm-hmm.
it the host unit testing.
Yep.
Uh, and so, what people tell us is this: we need to run this unit test on target. When I say why,
Mm-hmm.
there's a silence normally in a group or in a room. It's like, how dare you to challenge us, right? You want to run it. And then some people make a good argument. It's like, hey, we want to run it on target because we have this specification and we have this compliance document or some sort of a internal or external driving force
Mm-hmm.
that's telling us you must run this on target, like for AC level
Yep.
D or for class 3 medical device. That may be true, right? But for the other components, not. So, and then not every piece of software is very hardware coupled.
Yep.
I think, right, that you need to have that software uh, tested unit, especially unit tested on the real hardware. Maybe you can have some application level software being tested at the higher level. So, with that being said, what is your experience? What is your take on this debate of are we going to test it on hardware versus on a host, and what's your
Mm-hmm.
experience been like?
All right. So I've gone through a few projects where we've done hybrids of both, and then ones where we've, so I think I've got all the permutations covered. So I can talk to my experience on that. I would say just kind of right out, like, we're going to do unit testing. Biggest bang for the buck is to be running the unit test, and probably just start with, on if you had to get some unit tests off the ground, I would start just running them in your development environment. So if that's embedded Linux, you're probably building on a Linux system and you're running the test natively in your environment, really focusing on the logic in the classes. So because the logic really won't the logic is what the logic is. If you're using dependency injection, you're stubbing things out, you're putting in mocks. It really doesn't change anything. The logic should be the same. So I think that is kind of your biggest bang for your buck, and it's also your fastest route. So once you start running on the hardware, it's going to slow things down. I think there's kind of an in-between thing which you guys actually support really well, like in like the IAR world, where you're doing a sim using the C-Spy simulator, and I'm kind of shifted between the Spy simulator and the actual hardware, and where, to me, where the benefit starts going. And maybe I'm just dealing with old wounds because I've been doing this so long, but what'll happen is the native build will be a different compiler or different compiler settings. And then once you start getting into the target, either, so if you're going from a Windows or an embedded Linux or a Linux native environment to running on the target, you're doing a different build. pulling in different libraries, so that the tool chain is pulling in different C and C++ libraries, and then running those on the target, you will, if you don't find different bugs, you will at least build up more confidence. So I think, to me, that's the big thing. We in our environment could probably argue, and the environment being a medical device type environment could probably, you can make some pretty strong arguments about the validity of the unit tests, even if they're running natively. But I think from an overall project and a validation standpoint, you get a little more if you're running
Mhm.
them on the actual tool chain. And I think that, to me, that's been the more interesting thing, because the tool chain, especially if you're pushing the edges of C++, or if you're using some different features in the language, running those with those libraries on at least a simulated arm or an actual arm target is, you will, you'll bump into little edge areas where you're like, I didn't
Mhm.
know it quite worked that way. So
Mhm.
that would
Yep.
be my kind of take on the whole area there.
It resonates really well with me. Um, your suggestions. I typically tell people start with something that works works
Hmm.
fast and
Yep.
gets the job done, and then think about how to transition it to a simulator, or maybe start with the simulator first, and
Hmm.
then see if you can complement it with on target or on the host approach there. And what's good about simulation, it's relatively easy to integrate it into your CI/CD pipelines, into your automated
Hmm.
builds, into your DevOps ecosystem. But if your unit testing component is bound to run on the real board, then what happens when
Yeah.
you try to run builds in the cloud? You cannot ship board to the cloud, or at least you'll have to think of something very intelligent there.
Yeah.
Uh,
Absolutely.
yeah. All right. We're near the end of our chat here. I want to thank you, Bill, very much for spending time with us today. Your insights
Mm.
are extremely valuable. I find joy in just kind of listening to you and absorbing that information. I hope that people will also be kind of very susceptible to the views that you have, and they will follow your advices that you provide. So, in closing, again, I'd like to thank everybody who watched it, and I don't know if you want to, Bill, uh, say some
Oh,
closing remarks. And
thank you for having me. I mean, this is, I enjoy being part of this kind of forum. This is a neat thing you're doing. So thanks again.
Mhm. Thank you very much, and have fun, everybody. We're gonna end this broadcast now.
All right.